it's really true, we spend a lot of time on the pricing equation, and it's really true that the pricing equation fits very well in the cross-section, okay? But when you try to predict prices over time, say there was a change in the environment, okay, you do much less well, okay? So if something, if you have a price change or an induced tax change and you go to the next equilibrium, okay, eventually, because the cross-section works, it must eventually go to something like what we have in the cross-section, okay? But the timing, it must take some time to get there, okay? So you should be aware of that, okay? So I didn't want to leave the impression that our pricing equations are great. They aren't great, at least for the time series variation, okay? Okay, so the purpose of this, talk, okay, is to show you how to integrate micro data, okay, together with aggregate data. Okay, I said this before, but I'll repeat it now. Almost always you have the market shares, what I call market level data, which is prices, characteristics, and quantities. Okay, so and it's going to end up that you're going to need them both when you have microdata. Okay, I will tell you that now. I'll tell you why as we go along. Okay, so the paper is going to be structured for having both micro and aggregate data. Okay, because that's what's available. When there's microdata available, is almost always aggregate data available. So microdata matches individual characteristics to the products the individuals chose. So that's the definition of microdata. I actually have the individual characteristics, I know something about the individual, and I know what product it chose, okay? So it immediately gives you information on the interactions between product characteristics and person the importance of different kinds of product characteristics to different kinds of individual characteristics. So immediately you can just look at it and look at the difference, do families that are large size buy minivans? Okay, it's in the data, and you should be able to nail those coefficients precisely. In addition to that, you usually, though not always, okay, have data on which individuals purchase a car, period, or purchase one of the inside goods, period, okay? So that's helpful because it tells you, the distinction between who's buying this period and who's not buying this period, okay? Sometimes it also has second and third choice data. So they ask you, you get the first choice data by watching what the guy bought. If this is actually a survey, you might actually ask them, and for example, in one of the papers that I'm going to go over now, they did ask, what's the what would you have chosen had you not chosen this car? Okay, so that's the second choice data. Okay, this is increasingly available, but it's particularly in public finance. So I think I mentioned this, but school choice, you get a list, okay, of the schools that the student preferred. Order one. This is my favorite choice, my second choice, my third choice. If you're doing the matching and residency programs, okay, for doctors, you're going to get the first choice of the guy, the second choice of the guy, the third choice of the guy. Okay, so it's increasingly available. It's an incredibly useful source of information. And the reason it's an incredibly useful source of information is because it's going to give you information on the unobservable characteristics of the individual, as well as the observed. So the first choice data is going to tell you about the observed relationships, okay? But when I look at the second choice, okay, I'm going to be, if I would predict it from just the first choice things, I would get a certain prediction for the character. But if the characteristics of the second choice are closer than that to the first choice, closer than you would predict from the observable things, it's because of the unobservable things. Is that the new eyes? Is that clear? See, it's almost direct evidence on the importance of unobserved individual characteristic interactions, okay? Now, the only thing that's a little bit close to that is panel data. So in panel data, if you had panel data over time, this is also helpful in a particular way, okay? You have to make an additional assumption if you have panel data, and the additional assumption is the preferences are stable over time, okay? Now, sometimes that makes sense, sometimes that doesn't make sense. The kid leaves home, the preferences are going to change for the type of things you buy, okay? But it's clearly good, at least in some instances. The other so if you really are willing to assume stable preferences over time, the other difference between panel data and second choice data is in panel data, the whole choice set would typically change from period to period, where here you're just taking one thing out of the choice set. You take the first choice out, and you look at what will I do? What's the second choice, okay? So in panel data, you have this problem of distinguishing effects, okay? Because there's many things going on at the same time. Okay. Here's the model. You guys are going to get sick of this model. You've seen it a lot of times, but I'm just going to rewrite it down on the board, okay? So the utility of, I'm going to write it in a slightly different form, the form that it's typically used when you have direct microdata, okay? So Uij is the utility of individual I for good j. And you can do this in many ways, but this is the way that's typically been done. Actually, it started in this paper, Micro BLP. You give every xjk is the characteristics of the products, and you let every household have different preferences for each characteristic, okay? So that beta now is beta ik. Is that clear? And then there's cj, which is this unobservable thing, which is picking up, again, the unobservable is picking up everything that we don't put into the model, okay? It's just like all unobservables, okay? And then there's the epsilon ij, which can cause problems, okay? So now what we're going to do is we're just going to say, okay, let's do a regression function, okay? We have a bunch of family characteristics or household characteristics. So let's say beta ik is really beta, let's just do a regression function on those characteristics. Is that clear? And we're going to allow for a residual. And what's the residual? The residual is all those family characteristics that make me want xj or more or less that aren't included in the z's. Is that clear? And that residual, by the way, importantly, can have different variances for different coefficients, for different k's. Is that clear? We can be very good at getting all the things that determine my preferences for car size, and very bad at determining my preferences for luxury in the vehicle or, high-end leather, okay? Or sports car, okay? That's one we really don't know, okay? Okay, so the difference is the ZIR are observed and the new IK are unobserved determinants of individual preferences. And the way the notation's going here is that the beta 0 are going to end up being unobserved things, and the beta U I'm going to come back to now. Well, maybe I'll rewrite it. I think I rewrote it here. Yeah, okay. So what I'm going to do is I'm going to just substitute this into that. That's the extent of economic theory that goes on in this stuff, okay, which isn't a hell of a lot. So I'm just going to substitute the second equation in the first equation, and you get the following equation, okay? And reappears our delta J, but now we know what it is, okay? So the delta J, so you just substitute in, and you get a constant term, okay, which is a function of all the x's. It's the constant term in the projection of x onto stuff, okay? So we did this projection. We need a constant term in the projection, okay? And that constant term just interacts with x. It's the same effect on everybody, so it goes into the delta J, okay? As does the Cj, okay? There, okay? And then on top of that, I have two types of interactions between x and household characteristics. I have the interactions of observable household characteristics and the x's, okay? And the interaction of the unobservable household characteristics and the x's, okay? And what I did is the beta u there is really the variance of the new IL. So remember, there's one unobserved characteristic per product, but they can have different variances, okay? So I have to normalize it by the variance, and the beta u is the variance. So the way I did it, the reason I did it this way, is because beta u are the betas on the unobserved characteristics for u, okay? And the beta 0 are on the observed characteristics, okay? That's the easy way to remember it. And there's a beta 0k and a beta 0 rk. The beta 0k is from the constant terms, okay? Okay, so if you remember, think back to my first lecture. The whole problem, or most of the problems with own and price and cross price elasticities emanate from the fact that there's not enough interactions between individual characteristics or household characteristics and product characteristics. Because when I put individual characteristics together with household characteristics, particular individuals like particular characteristics, and when we increase the price, they'll go to other places, other cars or other products with similar characteristics to the one they bought, okay? So now the difference is we have two sets of those kinds of interactions. We have interactions with observed Zs, and then interactions with the unobserved Zs, okay? So and they're supposed to fix this up. Okay, that's their role in this game, okay? Okay. Okay, so that's the model. That's going to be the model behind everything I do, Okay, that's it for, sort of modeling. Okay. Now let me come back. The way you handle this kind of data, yeah, go ahead. By the way, questions are welcome.
I was just going to ask, do people typically assume that new IL is uncorrelated with new IK?
Not always, but it works out that it's hard to estimate in other ways. Okay, so the new IL. So that's a good question. Let's go back here. So I could have said, there's these news. They could well be correlated. Okay, and there's nothing in the model that says they aren't correlated, and you could model them as a correlated matrix. Okay, so this goes back to something that was Dennis asked earlier, and in principle you should be able to do it. Okay, because it's not J by J anymore. Okay, it's K by K. Okay, but people haven't had terrific. What I've seen is people haven't had terrific success in estimating the covariance terms. It's a precision. So you should understand that, here, let me, we should have done this at microBLP because we had more data, you'll see, and I don't remember we did it. You got to remember these papers were written quite a while ago, so maybe today I would do that, okay? I would at least check to see what happens. But I think the thing you have to remember about estimating variance covariances, okay, is the variance of a variance is a fourth order moment. It's something to the power 4. Okay, and you don't estimate those things very well, okay, because the variance of it is, so if you have 10, it's 10 to the 4th, okay, and you have to average out numbers like that, okay. Now, I say I should have, we didn't do this in microBLP, but we actually are, you'll see that we had enough data that we probably should have tried, okay, but these were days, in those days, it was a week a run, now it's, 15, 20 minutes a run, okay, so we should have tried it. But that's a good question, okay? There's no particular reason to assume they're not correlating, okay? Okay. Where was I? Okay, so types of microdata. You handle the different types of microdata slightly differently, so I'm going to go over a little bit of this, okay? There's random samples of consumers, okay? So the CEX is a random sample. The Consumer Expenditure Survey is supposed to be a random sample of consumers because they're getting the weights for the price index from it, okay? That's a very unusual structure, okay? And the reason it's an unusual structure is if I wanted to learn about a particular product and who likes a particular product, what kind of people it appeals to, it's a very inefficient way of gathering data, okay? So no marketing firm would do this, and the reason it's an inefficient thing is because even if you do autos, which are a big purchase, most people don't purchase the good. So 90% of the people that you go phone, survey, and talk to or give a present for answering things, okay, are giving you no information, very little information, just that they didn't purchase anything, okay? So what all the marketing firms do, and indeed what the statistical agencies do when they don't have to have a random sample, okay, is what they'll do what's called choice-based sampling. So what choice-based sampling is you sample from a group of people who purchased a particular product. Is that clear? And then you do inference from this sample. So, and what we're going to do, we're going to do cars. The data we got was directly from General Motors, okay? And what they did is they told this firm, okay, to go out and sample all registered cars in the United States, and they told them to get 40 Pontiacs, 50 Chryslers, okay, et cetera, okay? So the question you're asking in these samples, in the choice-based samples, is what does your model predict for the characteristic of somebody who bought a Pontiac? Because that's what the data is, okay? So I'm going to have to transform the model to make it look like that, okay? That's what's called a choice-based sample, okay? So most of the samples that you're going to get that have microdata look like this, okay? The choice-based samples, they come in very many different ways. The marketing firms typically don't give you the individual stuff. Often, by the way, they have, they sign something that says, we will not hand out the individual data, okay? Also, by the way, there's a lot of data now on insurance companies, okay? It's similar. They won't, health insurance especially, they can't tell you, okay, who the person is, okay? Hospital, where people go to hospitals, okay? So healthcare is a big deal. It's 17% of the economy. And this is an industry which is so regulated, there actually is a lot of microdata around, Okay? Almost all insurance stuff is regulated. Regulated industries often have some form of microdata around, okay? Because they have to report things to the government, okay? They often, and what they let out are things like the average income of a consumer who did this, the average age, what fraction, with insurance, what fraction smoke, okay, stuff like that, okay? And so that's what you're fitting. You're saying people who bought this kind of insurance, okay? Okay, I know their average number of them, their average age, okay? What does the model predict for that? What does the model predict for the average age of people who bought this type of product? Or the average income of people, okay? So we're going to have to do that, and I'm going to do that in a second. Okay. So this is also the information. I'm going to start with Petram, but I'm not going to do the stuff that we split it up, okay? I'm just going to show you what you do. But so often what we're going to have is not just so in the choice-based sampling thing, again, I'm not going to go over how you transfer the model into a choice-based sampling moment. Okay, so if the data comes as choice-based sampling, so you know how many individuals, or the characteristics of individuals who brought product J, okay, or the correlation between income and product size from this kind of thing, okay, how would I actually bring it to data, okay? Okay, so I'm going to give you, we already got the moments from the aggregate data, so I'm now going to give you the moments from the microdata that you're going to add, okay, you're going to estimate them simultaneously. Okay. So these moments are going to depend on three things. It's going to work out. They're going to depend on the number of individuals in the choice-based sample. So there's 40 people who bought a Pontiac, then that's little n for me, okay? They're going to depend on the number of simulation draws, okay, because I'm going to have to do the aggregate shares also, okay, and I'm going to do that by simulation. I'll show you how to do that. And they're going to depend on the size of the market. Often we forget about that, because if it's 100 million people, that source of variance is going to be averaged out, okay? Okay, so here's how you do it. Okay, so I'm going to say let xkg be the kth characteristic of the jth car, okay? And I'm going to say, I'm going to look at the people who said, this is for the, I'm giving you the words from the, assuming we're doing cars, but you could substitute anything else in here, okay? I'm going to assume that I know that y1i is the first choice of the car J is the first choice of individual with the ith individual, okay? And I'm going to say, so what's my moment going to be? So if you look at the interior term, what's in the data, excuse me, what's in the data that is the average income of people or the average family size of the person who bought this car. Is that clear? So that's this term here, the mean Zij. Okay, all those people bought car J or bought product J, and what I know is their average income or their average household size or whatever it is that I'm, okay? And what I want to do is I have a model which tells me who will buy good J, okay? And I want to know what that model predicts for the average income of people who bought car J. Is that clear? So that's what's on the second term, okay? Given the value of the parameter vector, okay? Because that's going to change with value of parameter vector, and I want to find the value of the parameter vector that makes that as close as possible to the actual data, okay? And then what I'm going to do, this is typically what's done if I have many products, is I'm going to interact it with a particular characteristic, xkj, and then get a weighted average of that over the sample points, nj over n. Okay, so that's just the correlation between income and if this is family size, between family size, and xkj is car size. And typically, you'll have one of these moments for everything, every x and z that you interact with in the data. Okay, so if you're going to go to a utility function, there's going to be interactions with x and z, and what you'll do is you'll typically have one of these moments for each of those interactions. Okay, everybody with me? Okay. Okay, so then I got to tell you how to, the only thing that I need to tell you, everything else is data, except for that EZ, okay, which I have to tell you how to calculate. Is that clear? Okay. So the first thing I'm going to do is EZ is just the probability, you can just assume this is all sums, okay, forget about the integral sign, okay. It's just the expectation of Z given that the individual chose J. Is that clear? Okay? So then just use Bayes' law. Okay? So the probability of z given the y equals j is the probability that y equals j times p dz times probability somebody, a random person does j. So this is just using Bayes' law. Everybody's familiar with Bayes' law? Okay? That's all I did. So px given y is py given x times px divided by py. Okay? That's what this equation is. Okay? So now I'm in business. Why am I in business? Because our model tells us about this. That's what the model is. It tells you the probability that y equals something given x and theta. Okay. So I got to calculate that. Okay? So here's my calculation. Remember, we're going to use aggregate data along with the microdata. Okay? So for every theta, because I'm doing this inversion, okay, I'm going to fit PRY equals J conditional on theta, okay, exactly, because that's just the market share. And the inversion makes for every theta, the inversion makes the deltas, make the shares, the observed shares equal to the actual shares. Is that clear? So this is just SNJ. And it's always going to be SNJ, no matter what theta you choose, because you're always going to find the delta that makes everything equal. Is that clear? That's what the contraction mapping does. Okay. So this is approximately equal to that. Now, this is a complicated object, but the actual probability is not so complicated. It's just the formula that Aviv wrote up on the board 7 times, okay, and I wrote up 4 times, okay, and it's just that formula, okay. But the problem is I have to integrate out over z's and nus because I need to find the average. Is that clear? So what I do is I just take random draws from z and nu, from z and nu distributions, and I integrate out. So now this, you got to be careful because this PDZ, that's the distribution in the population at large. Okay? So I need random draws from something like the CPS. Okay? That's almost always available in almost every country I've ever been in. Actually, in every country I've ever been in. Okay? It depends what's in Z, by the way. You could find things in, but standard demographics, that distribution is always available. Okay? So that's your approximation to the moments. Okay? You just add that to the aggregate moments, okay, the C moments and the omega moments if you have a pricing equation, and you're off and running, and you do method of moments when you have a choice-based sample. Okay? That's all you do to change things. Okay. So let me go back to Petra and the minivan. I'm going to just do this very quickly because Igal did it. When I do little stuff, it's because it's sort of it's interesting, but it's not directed at what we're supposed to do. So the little stuff here is a history of the minivan. You guys probably don't know this, but the minivan was first proposed by a guy named Don De La Russa, who worked for Ford. And Ford, and he was one of the design guys at Ford. He went to the head of Ford and he said, we should produce this thing. The guys at Ford said no. Why did they say no? They said, even if it's successful, what it's going to do is it's going to eat into the station wagon market, and we control the station wagon market. Ford had the biggest share of the station wagon market, and it wasn't the biggest company, so it was a big deal to them. So Lee Iacocca quit. You heard of Lee Iacocca. He quit. He went to Chrysler, and he took Don De La Russa with him. Okay, and Don De La Russa built a minivan at Chrysler. Okay, it took 8 years for Ford and GM to catch up. By the way, Chrysler was a failing company before this. This is the first company that I think the government walked in to support. Okay, and it ended up being the the most profitable car company for the next 10 years. Okay, it was not only because of this; it was also because they bought AMC, the Jeep dealer, at the same time. Okay, or shortly thereafter. Okay, so here's the question. Yeah.
I just want to clarify, this NJ over N is basically putting more weight on those cars that have more observations in my sample.
Yes.
So
Yeah.
I don't need to go too long, it's not really very
Yeah, that's probably right. Okay.
And it'll give me one moment for every demographic car characteristic, either action.
Yeah, that's the way we do it. You don't have to do it that way, but there's a lot of intuition in that.
Yeah. I mean, would it add anything to say just the demographics, like the average height of the person?
We did that also, because that will tell you the average height of people who bought a car. You would average over everybody who bought a car. You'd have to compare it to the population at large. Okay? Okay, so what's the goal of this? I'm going to concentrate on the economics, and I'm going to go back to micro-BLP, where I do the econometrics and the modeling. The goal is to quantify the impact of the minivan on Chrysler's profits, the consumer welfare, and on the profits of competing firms. So this comparison is a comparison that was always of interest to economics. So Chrysler's profits is a private return to R&D, and consumer surplus is a social return to R&D, or the sum of the two is a social return to the R&D. And the reason we have all these patent laws and R&D tax rebates and everything is because they're supposed to be different. Is that clear? And we might want to find out just how different they are. Okay? Of course, there's a problem in doing that here. And you should keep this in mind. We're going to find out they're very different. Okay? And that, in fact, the social surplus from the minivan, at least the way Emil Petrin computes it, and there are all these problems that Aviv just went over, okay, is going to swamp the private profits. Okay? So that's, even if, I'm going to assume that's true for a second, you got to worry a little bit, because there's lots of R&D that went into autos in these days, probably still now. But in those days, it was one of the biggest R&D sectors in the economy. And there was maybe 2 innovations in the last 25 years that were as important as the minivan. Okay, so somehow I got to wait. When you're going to do the social versus private return, I got to weight the unsuccessful innovations with the successful innovations, which requires a way of sampling innovations. Okay, it's much more complicated than this. Okay, so you shouldn't take this as the last word on what's driving the difference between social and private rate of return. Here's an example. Okay, it's not an example. It is an example of one of the high-end things. Okay, but you'd want to mix it with everything else. Okay, if you actually went out to do something. Okay, so that's the goal. The exercise is estimate a demand and cost side from the observed data, and then recompute equilibrium prices and quantities from a choice set that doesn't include the minivan. So I'm going to estimate this model, okay, and I'm going to estimate a pricing equation at the same time. I'm going to say, okay, that's from the data where the minivan were there. Now I'm going to say, what would have happened to profits and consumer welfare if the minivan weren't there? Okay? So there are 2 problems with that kind of calculation, other than the technical ones that Aviv went over. You would have, if the minivan weren't there, the other cars would have changed their pricing. Okay, because now they're competing against different kinds of goods. Okay, so this he can solve if he puts in the pricing equation. He can compute a new equilibrium. Okay, and he does. Okay, the other problem is, had the minivan not been developed, different new vehicles would have been introduced over the time period study. Because now if the minivan wasn't there, there's an incentive to produce different kinds of cars. Okay, and that we can't control for. Okay, without a dynamic model. Okay, because the way you would do, you would have different incentives for producing different characteristics of cars, okay? And you could run that through a dynamic, in principle, you could run that through a dynamic model to figure out what happened, but he didn't do that. And in fact, it's pretty hard to do, though we're making a fair amount of progress on the dynamics, okay? We're not going to talk about it here, but that's one of the sort of forefronts of research right now, okay? And he's going to talk at least about dynamic demand. But this problem here is not the dynamic demand side, it's the dynamic production side, okay? Okay, so you got to take that with a grain of salt also for that reason. So what Petrin did is to the standard data, all he did is just add the data from the CX on these characteristics, the interaction between product characteristic and consumer characteristics, okay? He interacted, one set corresponding to purchase probabilities interacted with individual characteristics, and one set of characteristics interacted with car characteristics with individual characteristics. So purchase characteristics is whether you bought a car or not, okay? So this goes back to something I didn't stress in the first lecture, but I should say it, okay? And this came up in one of the conversations also. When you're doing this, you also have a UI0. Remember, we forgot all about this. Everybody with me? There's a UI0 out there, and we're going to subtract it from UIJ because we get this additive normalization. Is that clear? So the purchase characteristics are going to be the things that are added to the UI0, their UI0, okay? So the way we did it in BLP, I can't remember what he did in micro BLP, is we said, exactly the same characteristics that we interact with product characteristics, we're going to leave free on the UI0 term. and they're going to differ by county, state, whatever you want, the distribution of them, and we're going to estimate separate coefficients for the outside term and for the inside terms. Okay. And I can't remember whether he did that or not. Okay, but we did it. I remember that. I will show you that when we get there. So I just wanted to go over a couple of the things from this, just to show you what goes on. Okay, so this is what happens when I take out the minivan. Okay, and this is what happens when I put in the minivan. Okay, so this just goes back to the thing on pricing equations for a second, just to show you what's going on. So you look at, these are the cars with the largest price decrease when the minivan comes in. So the minivan comes in, okay, and these cars decrease their price, okay, when the minivan comes in. You'll notice that they're all sort of mid-size cars, and none of them belong to Chrysler, okay? So what the competitors do, the mid-size car are the family-size cars, okay? So the people who are buying family-size cars, the minivan now comes in. The people who are selling minivan, medium-sized cars, GM particularly, okay, what they do, and Ford, is they respond by decreasing the price, okay, of their family-sized cars, because they now have a competitor which has, is better in some dimensions, and in order to sell more family-sized cars, I have to decrease my price, okay. In contrast, if you look at what the Chrysler cars do, they increase their price, right? The Chrysler family-sized car. Why? We just got a Chrysler minivan in, okay? I'm going to increase my price, okay? Some people will stay, okay? But some people will leave. But now most of the families who leave their car are going to go to the minivan, and they earn profits on the minivan anyway. So we might as well hike up our prices, okay? And this is exactly the logic of this multi-product firm thing that we were doing before, okay? There's a sense in which economics at that level works. Okay. Welfare profits and the returns to research. Okay, so let me just say there's going to be two sets of things. So when he does these welfare calculations, okay, there's two things going on. There's an increment to the people who bought a minivan and who would have bought a family car had there not been any minivans, okay? And then there's increments also to everybody else because there's been a change in all the prices. So if I bought a GM family-sized car, I just gained because the minivan came in, because the prices of all GM family-sized cars were reduced. Is that clear? So there's that source, and then there's the source to the individuals, okay? The source to the individuals for people who would have bought a minivan at the highest price minivan, okay? In some sense, we're waving our hands because we're getting inframarginal rents, is that clear? From above that. And there's nothing in the data that's telling us what it is. Okay, it's just a projection of these epsilons and other things out there, okay? But for everybody after that, you actually have a level, if you believe the model estimates, you have a level at which they didn't buy and a level at which they did buy, and that bounds their consumer surplus gain. Okay, because it's not greater than the level that they didn't buy, and it is greater than the level they did buy. Okay, so that part of it you could have done non-parametrically. Actually, I would have liked to have seen him do that split, but he didn't. It's a very good paper, by the way. I don't mean to be negative. We both talked about it, okay? But to give you some idea of what happened, if you look down here, first of all, this is what happened to profits, okay? You can see that in the minivan entered in 1984. It took, actually, Ford and GM immediately tried to do another, something that looked like it. They did something called the Aerostar and the Astro or something. Water, good idea. We'll see if that helps. But they didn't get it. I mean, they built cars that drove like trucks. They thought people just wanted the space, and the closest thing to them were these Volkswagen minibus type things, and they drove like trucks. And then it took them until 1990 to come in with something that was really a competitor to these things. Okay? And you can see what happened when it came. And by the way, Chrysler maintained their lead in this till the mid-90s. So it was 10, 15 years that they got a lead on everybody on you can see the industry profits actually fell in the first two periods. Of course, Chrysler's profits, these are millions of dollars, went up quite a bit, okay? But Ford and GM lost more than Chrysler gained, okay? And then eventually industry profits went up. So now we look back at the welfare and the compensating variation games, the welfare change, and the change in producer profits. So let me just say the investment in the minivan has been estimated at $750 to $1 billion. That's sort of around the range where it's supposed to have been estimated at. So you can see the rate of return for Chrysler was about 20 or 25%. Depends. Down here it's up to 50% per year, okay, which is a noticeable rate of return. Okay. If you go down to the welfare change, okay, you can look at just the compensating variation change. Okay. So this is the stuff that Chrysler didn't internalize, but the society did. Is that clear? This is a compensating variation. This is consumer surplus gain, and you can see these are so it's for a $1 billion investment. Consumer surplus returns are about 50% per year. Okay, so this is what set the trade guys and the growth guys going. Okay, it's numbers like this. Okay, they originally started with numbers in hybrid seeds and things like that. Okay, so why we got the modern growth theory and R&D and all of this is because of numbers like. But again, you have to be really a little bit wary. Okay, because again, this is an industry that does a lot of R&D, and there have been very few innovations that have been as successful as a minivan. Okay, this changed the whole industry around. Okay, so you have to be a little bit careful, but there is a potential there, and this is one thing. Okay. I'm now going to go through in much more detail how you actually add consumer level data and how you do everything. Okay, this is from this microBLP paper. MicroBLP uses the KMIP data. Okay. So this gives you some idea of what goes on in industry. KMIP is a General Motors sample of, I can't remember, 37,000 people a year. Actually, they have two samples of 37,000 a year. They pay somebody to do it, okay, to do this sample. They tell them exactly, I want, all new car registered this year, okay? What I want you to do is I want you to sample, 20 Pontiac Grand Dams, 45 Cadillacs, 50 Volkswagens, okay? You go sample them and bring me back, and then ask them questions, okay? And then bring back the answers, okay? It's 30,000 people a year. It's bigger than the CPS. And what this taught me, well, it's more than 30,000, whatever it is. CPS is about 34, if I remember right. What this taught me is if the government was a private corporation, we'd have a lot more data around. They never let it out before. I'll tell you one story. They never let it out before. They let it out after they saw BLP because they thought maybe, and they gave us old data. Okay, so we wouldn't be. And then, by the way, what happened in the end is they asked us to rerun this stuff on new data and then get rid of the programs, give them to GM, and never come back to them again, so that they could do it by themselves and nobody would know the answers. Okay, so, and actually I didn't do it. This woman, Nadia Soboleva, actually redid the program so that and interacted with them to make sure they could use it. Okay, and that was it. Never heard from them again. It's sort of interesting. The woman who, there's a vice president, Maria von Wittmann-Neumann, who is von Neumann's daughter. And Jim was sort of friendly with her, Jim Levinson, who's one of the co-authors on this paper, and was also a friend of Mustafa Muhatra, this guy who ran the research program at GM. Anyway, when we went, he had to go ask Marina whether he could give us the data, okay? And she said yes. It was a big deal because they'd never let it out of GM before. They have one every year. They've never let it out. McFadden asked for it once, and they said no. It was BLP that they got it to. But when Mustafa, I said, "What's Marina like?" And she said, he said, she's about a third as smart as von Neumann, okay, which makes her the smartest person at GM. Which sort of, I don't know if you guys know the stories about von Neumann, but they're amazing. This is the data set. It has vehicle characteristic prices and sales. So it has the aggregate data, that the same as the aggregate data we had in BLP, actually more detailed because they know more, okay? But it's the same kind of data. Household characteristic by vehicle purchased. So again, they told them to find out these people's age, their income, their family size, education, you'll see, okay? And then they asked a very important question, which is, if you hadn't chosen this vehicle, what vehicle would you have chosen? That's the second choice data. Go ahead.
So could they respond, I would not have chosen it?
No, you couldn't respond that. That's going to end up being a problem, okay? Okay. So that's all very good, but unlike the aggregate study, and this is going to end up being important, okay, we only have one cross-section. So the aggregate study, we actually had 20 cross-sections of aggregate data, market level data. We're working here with one cross-section. You're going to see where that's going to impact things, okay? So here's my UIJ again that you guys must be getting bored of already. It's the same UIJ that was there before, okay? So what's going to happen here? The benefit of the first choice data is it's going to give me the beta 0 RK. Okay, at some level it's got to do that, okay? If all the beta 0 RK are 0 and I only had first choice data, you can show formally that sufficient statistics for this problem are just BLP statistics, the market level data. Okay? So if you only had first choice and the beta zeros didn't, and those characteristics didn't matter, the observed, you're back to BLP. Okay? So that's where they're going to hit us. Okay? The unobserved attributes differentiates the model from the standard micro-based Logit model. Okay? So this is, if you just took this as a micro model, you're going to go do Logits, and any kind of choice thing with microdata. It doesn't need to be cars. It can be from public finance, trade, whatever you want to do. Okay. The difference would be if you just did a standard Logit, there wouldn't be any new I's, and you just do a Logit and do maximum likelihood or whatever you're doing. Okay. Okay. So the new I's do two things. There's a substantive issue, and what they're trying to put in there is they're trying to say, look, if I got all the individual characteristics in my observed stuff that are important in determining the preferences for this characteristic. Because if I don't, I know I'm going to screw up on the cross-price elasticities because I don't have enough people moving. Is that clear? And the new I's should correct that problem. Okay? That's what they're there for. But it also generates a computational issue. The probabilities, like Aviv showed you, the probability, if new I were all 0, so I didn't have to worry about that, I could just do a straight Logit. And there's no problem with estimating that. You call Logit in Stata or whatever you're using. MATLAB, I guess, probably has Logit now, and you run it. Okay? But once you have the new I's, there's no analytic formula for the probabilities, so I have to integrate out with simulation. Okay? Or something else. Good. So let me just say, we went through this before, but when there's only one data set, one period, and one choice set, there's very little in the data to tell you what the new I's are. Is that clear? If you had one cross-section, same household, so you're not, same household distribution, so you can't go over different county distributions of household characteristics. Okay, you can't use that. Same choice set, so I don't move the choice set around. Is that clear? There's very little in the data that's going to tell you, okay, about what the distribution of the new I's really is. Because it's just functional form, essentially. There's nothing sweeping it up. Okay? So the advantage of the second choice data is it does have something for that. I said that already, but it's worth repeating. The second choice data tells you if I take out a car, okay, what car will I go? How close is it to the X's of the cars that was my first choice? And if that closeness can't be predicted from the observed Z's, it's because of the new I's. Okay? Okay. So now one other point about microdata, which is often missed, okay? So the microdata, once I have the microdata, I could actually estimate separate delta J's for every product point-wise. I have microdata, there's a different constant term for each product. Is that clear? It's easy to do that. If you just call Logit and let separate constant term, okay? So I could actually estimate the beta 0 RK and the beta UK, I could estimate them without any assumption on the CJ, which was the identifying assumption in BLP. Everybody with me? Because I can estimate the deltas just point-wise, and everything else is just a Logit for the microdata. Is that everybody with me? Okay. So, but you got to remember that the delta j's are a function of the x's, and one of the x's is price. Okay? So to get price substitutes, or cross price elasticities, or cross anything elasticities, I also have to run this equation. Okay? Unless I'm going to assume that all the beta 0k's are 0, which is typically what's done, what was done, at least before we got around to it. Okay? Because it's a nonlinear function of the deltas. It's e to the whatever it is, okay? And the derivative with respect to price also requires the price derivative in the constant term. Is that clear? Okay? This is where there's going to end up being problems, okay? Because, you know, you have microdata, which is a ton of data, okay? But you still have only whatever it is, however many products there are, observations on delta J. You haven't solved that problem yet. Is that clear? The microdata tells you how to solve the interaction terms, but it doesn't tell you how to solve the problem of figuring out what the constant is determined by. Because you have the same amount of constants as you have products, just like we had in the market level data. Okay? Okay. So again, you know, I said this before, but I'll say it once more. There are some issues I can address without getting price elasticities, like price indexes, okay? But many of the issues we want price elasticities or characteristic elasticities, and for that I have to get the delta J's, okay? Okay, so now let me tell you how to do this. Okay, so remember, I'm going to try and estimate the beta 0 and the beta u, okay? And then I'm going to try and partition the delta as a function of the betas, of the x's, including price. One of the x's now is price, okay? So those are the three things I got to do. Okay, so you have two choices, okay? I could either start by estimating beta delta pointwise, so estimate every delta separately and the betas. Okay, the beta is the beta u and the coefficients of the observed and the coefficients of the unobserved. Okay, I could do that pointwise. I could just estimate them all. Okay, or I could use the assumption, an assumption identifying restriction on c, say e c given x is 0, and estimate instead of beta delta, estimate beta and beta 0. Is that clear? So if I have, you know, k characteristics in 200 cars, okay, this is estimating only 5 parameters. Okay, and this is estimating 200 deltas. Okay, we're always going to estimate all the beta u's, all the other betas. Okay. Okay. So what's the trade-off? It's an obvious trade-off actually. If I estimate beta delta pointwise, those estimates don't depend on the assumptions that go into the instrumental variables here. They can be wrong or right. The beta delta will still be right. Is that clear? Because I'm not making that assumption when I do that. Okay. Okay. The trade-off, of course, is if this assumption really is right, I'm going to get more efficient estimators this way. Okay? What we did is we weren't worried so much about precision. The reason is we had data sets that had 30,000 observations in them. Okay? So we did the beta delta pointwise. And then we're going to do a bunch of things to just use different assumptions on the deltas to show you the impact of the different assumptions on the estimates of the delta equation. Because once I have the delta estimates fairly precisely, I can regress. I can do instrumental variables in seconds. I can try 20 different, see how robust it is, everything. Okay. Computational choices in the search routine. So again, we're going to do the beta delta pointwise. How would you do that? I'm going to come back to it, I think. But I'm going to show you how we do it. But you can think of this as following. Hold delta fixed, okay, and estimate the beta. So I'll come back to this in a second. So what I could do is I could do this search over beta and delta together. Is that clear? Okay. Or I could use BLP's contraction mapping to compute delta as a function of beta, okay? And then just use the beta, we know it's going to fit exactly, get the delta exactly, okay? And then put those betas as a function of delta back into the moment equation. Is that clear? That's sometimes called concentrating out, okay? So what's the difference here? The difference is really a computational one. I don't know how many of you guys have done complicated search procedures. But the deltas have 200 parameters, okay? And the betas are about 30 or 40 in our model. Searching over 250 parameters is a pretty difficult thing to get the computer to do right and to make sure you're right. Is that clear? So this, we know we can do this right away, the inverse right away. It's probably not as efficient of doing everything together, okay? But we know we get it, the 200 exactly right for every beta, and then we're just searching over 20 or 30 parameters. Is that clear? So we chose, you solve BLP's contraction mapping for delta. You get delta as a function of the market size and the number of simulation draws, and beta. And then I'm going to substitute this back into the moments that are going to determine beta. Okay, so I have delta of beta and beta in those moments, okay? And I'm going to maximize with respect to beta. Okay, one comment about this, okay? So the first thing I want to do is I want to just do the microdata and get the estimates of beta, okay? Given I've done the inverse, I got delta inverse, now I'm going to put this into the microdata and estimate it. The first thing people would say is, why don't you try doing the likelihood? Because it's a logit, okay? Maximum likelihood is efficient, okay? It's not efficient, okay? It's not even a good idea, okay? It's not efficient because for maximum likelihood to be efficient, you have to have exact estimates of the probabilities. That's what, if you look at the theorems, that's what the theorems are saying. There's no simulation error, there's no approximation error from quadrature or whatever sequences you're using. You got it exactly. What happens when you don't have it exactly? Okay? So what happens when you don't have it exactly is there's a difference. I'm going to say we did simulation, okay? There's a difference between the true P, which is the PZI beta delta, and your estimate of P, which is the PNS, okay? Everybody with me? Okay, and I'm going to call that difference UNS. Okay? That's the unobserved part of that difference, okay? So I'm going to look at that difference, and it's approximately, if you do the expansion, just a Taylor series expansion, the first term is going to be UNS over P. The second term is going to be UNS squared over 2P squared, and then there's going to be terms of higher order in the Taylor series, okay? Okay. So now I'm going to take the expectation of the error. So this error is actually and you're not maximizing likelihood, you're maximizing the likelihood of the real P plus these errors. Is that clear? Because that's in fact what you're doing. It's not log P, it's log PNS, which is really log P plus log of P plus U. Is that clear? And I'm just doing that expansion. Okay? So you do that expansion, and then I'm going to take, remember, we're going to be something like, there's going to be a moment in the first order condition. I want to take, what's the expectation now, okay, of this, the true thing, not the instead of the expectation of the likelihood, which we know will be, by the entropy thing, will go the right thing at theta 0, will give you a maximum at theta 0. I'm going to now take the expectation of this thing, okay. So the entropy theorem is what tells you that maximum likelihood is efficient. Okay, I shouldn't have said it. Okay, so if you take that, you get a variance term here, which is, the first term is mean 0. If you've simulated right, it's mean 0, so it goes away. Okay? Okay, the second term is not, it's the variance, and it's a function of beta and delta. Is that clear? So now, to the likelihood, we're adding this other function of beta and delta. Is that clear? So you're no longer you're maximizing likelihood, you're maximizing something else. Okay? Now, that other function, it works out, is approximately 1 over 2 times ns times p. That's because a binomial formula for the variance is p times 1 minus p, and if you stick that in, you'll get this. Okay? Okay. Okay, so now let's think about what's going on. Okay? So if that number is large, it's large in a function of beta and delta. Is that clear? You've added something to the likelihood, which is large, and it's not reflective of what you're trying to do. Okay? So let's think of the auto industry. Only 1 in 10 families buy a car. So all of the P's together sum to 10, 0.1. Everybody with me? Okay. There are 200 cars. Okay. So there are many, many cars with shares about 0.0001. Okay? You can just look on the data. There are many. That's the shares of those cars. Is that clear? Okay? So in order to get the variance just down to the level of P, okay, I'd have to simulate 10,000 times. for each individual. And I have 30,000 individuals. So I would need to take 300 million simulation draws, okay, hold them in the computer fixed, and reevaluate them every different theta. Okay, that's, you know, you just killed your computational burden is just crazy with that, and you're not going to do it. Okay, and that's just to get p on the same order. If you tried to get it to be very small, the bias to be very small relative to p, you'd have to do it, you know, 10 or 20 times more than that. Okay, 10 times more than that, I guess, which would make you into 3 billion simulation draws. I mean, you're getting to numbers that are ridiculous. Okay, so you don't want to do maximum likelihood. Okay. So I've seen people do this all the time. I just don't understand why it doesn't catch hold. It makes a difference, by the way, because I've tried it both ways. Okay. So it's a rather extreme case. It's a little bit of rather extreme case because the p's are very small, okay, and the sample size is very large. Okay. I mean, if I had p's like 0.5, it wouldn't be such a problem. Okay. But in most cases, when you're dealing with most markets, most people don't buy a good in every period. Okay, so, you know, 1 in 10 maybe, I don't know, but, and then if you have 150 goods or something like that, okay, the numbers are going to get like this. So we don't want to use we don't, to estimate the micro parameters, we don't want to use likelihood, so what do we want to use? Okay, so you can choose, you know, just about anything, as long as you know how to compute the model's implication to it. Okay, we chose something which we thought was very intuitive. So every time we interacted a household characteristic with a car characteristic, family size and car size, we did the moment I told you before, okay, which is we looked at the correlation between household size and car size in the data and the prediction of the model for the correlation between household size and car size. And so we added, for every parameter like that, we added a parameter like that. Also, for the characteristics of the households that bought a car, we did the same thing. Okay? And then for the first and second choice moments, for every car characteristic that's in, remember there's a new I for every car characteristic, we added the correlation between the first choice and the second choice car characteristic. So I know your first choice X, the first choice car size, and your second choice car size. So I'm going to do the correlation between the first choice car size and the second choice car size. I'm going to get the model's prediction for that. Is that clear? And I'm going to compare it to what's in the data. Because that's supposed to pick up everything that gives you a correlation between the two car sizes, okay? The observable and the unobservable, okay? And the observable is going to be gotten from the first set of moments, and the difference is going to be because of the unobservable set of moments. Okay, that's the intuition between what we're going on. Okay, so again, here's the simulation problem. Here's how we estimate it. We start with the market level data, okay? We set S beta delta P and S to equal S, and we use the BLP contraction mapping to do that. By the way, so why is the BLP contraction mapping useful? It's because this is 200 equations and 200 unknowns for every different beta, okay? So it's a nonlinear system, 200 equations, and what the contraction mapping says is, look, it's a contraction mapping. I know how to solve this quickly without any search procedure. Okay, and I'm going to give you 200 numbers, they're going to be exactly right to whatever precision you put. And as Aviv said in his lecture, by the way, you want real precision. This is one thing we've learned from all the stuff, okay? You really want it down to 10 to minus 12 or something like that, okay? So then that gives me my delta. I'm going to substitute the estimate of delta for delta into these micro moments that I gave you at the very beginning. And I'm going to maximize a weighted average of the difference between the prediction for the micro moments and the actual micro moments in the data. I'm going to do GMM. Okay, so that's what's going on. So here's some tables. So again, the KMIP, this data set is a random sample of 37,000, I guess, 500. I said it was over 30,000, so I was right. And 34,500 of them have second choice data. So this is a huge sample. Okay? I think the first thing I want you to look at is KMIP versus a CPS. So I said you want to do correction for choice-based sampling, right? This is not a random sample of people. It's a weighted average of the number of a sample of people who bought Pontiacs, a sample of people who bought, okay? If on the whole, the KMIP is the whole thing, if they bought, if the characteristics in the KMIP sample were the same as the CPS, you'd worry less about choice-based sampling. Is that clear? Because the whole issue of choice space is I've chosen particular people. Now, I've chosen them on the basis of the new i's as well as the z i's. But if it was uncorrelated with the z i's, you might think it's not so bad an assumption. Okay? Because what you're doing is remember, what you're doing is you're taking not a random sample of people, but people who bought the car, who have particular z i's and new i's. Okay? So here, if you look at it, here's the CPS group mean, and here's the KMIP group mean. And you can see that the income stuff is really very clear. Okay, people who buy cars, not unsurprisingly, okay, are wealthier than people who don't buy cars. Okay, so the average household income at this time in the CPS was $34,000. The average in the KMIP sample was $72,000. Okay, so it's not a random sample of consumers. If you look at other demographics, the interesting thing, they aren't really that different, except for rural versus urban. Rural people buy a lot more cars than urban people, which explains why GM and everybody else was interested in light trucks, okay, and SUVs, okay. So the first time we did this, by the way, we ran it through with just the old BLT stuff, which was only cars. And Mustafa told us that they're not interested in something that doesn't have the interactions with light trucks, because it's 40% of the market, even then, okay. Oh no. Control, does somebody know what it is? Control L? No, control shift what? Plus. Right, good man. Thanks. Okay, the way so you have car characteristics, you have people characteristics, okay? And what you want to do is find out, which interactions are important. Is that clear? So you do a bunch of tables, of data, and you try and figure out what it is. And so this is the one that helped us the most, actually. So these are the people characteristics, household characteristics: age, kids, family size, urban, suburban, rural, and income. Okay? And you can see all the things that you expect, right? So, I mean, it's really nice to look at data sometimes, because then you start believing all the stuff they taught you about economics. Okay, so, higher income people buy more high-priced cars, for example, which should not surprise you, but it's nice to see stuff like that. If you look at who's buying pickup payload, who's buying trucks, they're all rural, well, they're largely rural people, okay? The thing that surprised me about this, by the way, the first time I looked at it, I remember, was that age mattered so much. Works out that age interacts with almost everything in taste. It's a little disappointing, but what can you do? So you can look at this and you can preview it. If you do minivan and kids, you're going to get 2+ are where all the minivans are sold. Okay, and you can look at it and you can see that it all makes sense. Okay. Control Shift plus. Good. Okay. When you do something new, typically it's usually more complicated, okay? And the first thing you do is you compare it to the old style stuff, okay? So we actually estimated 4 models. We estimated straight Logits, okay? We estimated, it was just first choice, Logit first and second choice, straight Logits, straight BLP, and then the full model. So our full model, by the way, it's a combination of the Logits and BLP, because we have unobserved individual characteristics and observed individual characteristics. So the Logits just have the observed characteristics, right? The pure Logit just have the observed characteristics. BLP just has the unobserved characteristics. And the one way to look at this model is we have both observed and unobserved characteristics. We include both. Okay? Okay, and so here's, again, what we did exactly what we said, except for price and income, and we let that be a spline. So a spline just says there's one coefficient for the first quartile, another coefficient for the second quartile of income, third and fourth, okay? Because you're always interested in the price coefficient more, so we freed it up and just said what does the data say, okay? The other thing you should note is, so for all the individual characteristics, they interacted with the product characteristics, but they also enter for the outside good. They get a coefficient in the outside good. And there's also a new I for the outside good. Everybody with me? Okay. So the only ones that were important were income, family size, and the number of adults. And it's everything you expect from the outside good. So the outside good was more if you had more income, your outside good was better. Okay? Conditional on income, if you increase your family size, the outside good went down because your total income, your income per family member went down. And if it was adults, it went down even more. Okay? So this goes back to this question of taking care of the outside good correctly. Okay? Originally, by the way, they were all in here, just that nothing else mattered except for these three. Okay? And you look at the price coefficient. So the price coefficient, we did it with wealth, and we did 1 over it. Okay? And you can see that what mattered, there was a difference between the first quartile and the third quartile. And family size entered exactly the way expected to enter. So I'll let you purview these numbers, but you'll see that almost everything makes sense. And in a way, it wasn't a surprise to us. We had really good data, okay? And if you can't get it with 37,000 observations, you shouldn't be able to get it, okay? So, minivans interacted with kids, horsepower is age, SUV with age is negative, rural dummy with SUV is positive, trucks are all rural, stuff like that. You can just go through this and you'll see everything makes total sense, okay? The surprise wasn't that. The surprise was the Logits made a lot of sense also. Okay, that was the surprise. Okay, I didn't expect that. Okay, but if you look down the line for the Logits, they're not that different. At least there's magnitude differences a little bit, but they're really not. Signs aren't really different. And to go from the coefficients to the actual, it's not. You don't really have a big. I will show you the implications, and then you have some priors on the implications. But in the actual coefficients in this stuff, you don't have very strong priors. You have priors on signs, okay? The one that's a little bit weird is, I think, trucks. If I remember right, trucks or had a rural dummy and goes the wrong way for the Logits. But it's only one that goes the wrong way for those. Where's pickup payload? It must be this one. So rural dummy, it goes down. It just goes down a bit. It doesn't really screw up. So, you look at the Logits, it's really not hard to tell. Oh, I know what was wrong. The outside good for the rurals, people with higher income had the Logits were predicting they had a less valued outside good. But outside good is sort of a weird animal anyway, right? So you might not kill it, okay? You look at this and you would say, even if one sign out of 25 was wrong, you'd say that's not bad for the way we do stuff. Okay, so the Logits looked okay. I'm going to come back to the implications. Again, they look okay from the point of view of parameters, but that's only because the only thing we have priors over the parameters are signs. Okay, magnitudes we don't have any prior. Okay. This is the same table. So now I'm going to look at the table with the variance terms on the unobserved stuff. Okay, remember there's a lot of coefficients going on, okay, because we have a lot of data. So there's the observed interactions and the unobserved new eye interactions, okay? If you look at this table, it's just striking how important the unobserved interactions are. I think virtually every one of them was significant, and some had t-values on the order of 20, 25. Many had t-values on the order of 20 or 25. Okay, these are standard errors underneath them. So this, for example, the price, we had 4 terms interacting with price, right? In addition, there's a random term on the price coefficient, and it has a variance. It has a t-value of 22 or 20, something like that. Okay, it's clear that it matters. You haven't picked up everything that affects price. Is that clear? Similarly, if you look at number of passengers, okay? It's got a t-value of, again, on the order of 20-something, okay? And we had many things interacted with the number of passengers, which is the size of the car. We had age, we had family size, we had lots of stuff in there. You're still left over with an unobservable which has a t-value of 20, okay? And you can go down the list and you can see almost all of them look like that. Certainly those on characteristics look like that. Okay. So the BLP ones, by the way, so now in the first table I couldn't show you anything about BLP because BLP had no interactions with observables. Okay. In this table I can't tell you anything about the Logits because they have no unobservable interactions. Okay, but this is the BLP These are the BLP numbers, which aren't so different from our numbers, by the way. Okay, so I'm not finished. I want to go to implications of the estimates, okay? Because you're going to see that the Logits screw up, and you're going to see why, okay? But before I do that, I can't do that. I can't get own and cross price elasticities, okay, until I tell you this projection of the delta J's. Because remember, they include also the constant terms. Everybody with me? Okay, and I have to do that. Okay, so I've got this equation for delta J, and I'm back to BLP's problem because CJ is correlated with PJ for the same reason it always was correlated with PJ. Okay. So I need instruments to calculate this equation, okay? Moreover, I'm in a much worse situation than BLP was, because now I have one cross-section of these deltas. Is that clear? Well, BLP at least had 20 cross-sections, so the same car appeared in different periods, so I could see some variance there, okay? But now I got one cross-section, okay? So there's going to be a precision problem with estimating beta 0, okay? And we're particularly interested in own and cross price elasticities. For that, all I need to know is beta 0p, because that's all the derivative will depend on beta 0p and the delta estimates, okay? So we tried pure instruments, we got nowhere. We added an assumption of marginal cost and a pricing equation like BLP did. I'll show you those answers. Still, you're going to get very imprecise estimates. Okay, it works out, okay, for the reasons you might think. So we look for prior information. So, you know, when I used to give this at econometric seminars, everybody would start saying, you know, where are you getting this information? But the truth is, you know, all we're trying to do is find out an answer to a question. Okay, if somebody else knows the answer to this, you use it. Okay, in this case, GM thought they knew the aggregate price elasticity. They said they've been doing this for years in their research program, okay, upstairs, and it's almost exactly one, and it always predicts almost correctly. So he said, okay, let's take our model, set the aggregate price elasticity, the weighted average of the price elasticities, equal to 1. What's the beta 0 that implies? Okay, and use that. Okay, I'll show you the differences in a second, okay? The other thing we did is we took what everybody else did before us when they had microdata, which said 0, okay? And we did that also, okay, the beta 0. Okay, so I'm hoping yes. So these are, so what we did to figure out whether these made any sense or not is we took the semi-elasticities, I think the semi-elasticities, and just regressed them down on characteristics, okay? And see if it made any difference between the various products, okay? About whether the elasticities are different when I use different estimates of beta 0. The BLP with instruments and pricing equation 0 and the other one. And what you can see is the actual aggregate mean elasticity matters. It matters what you use. I can't remember which one is which. 0, I know what it is. I think minus 11 was from what the number beta 0 comes out to be from our stuff, and maybe minus 3.58 from using beta 0 that GM gave us, okay, the aggregate elasticity. And the average elasticities change a lot, okay? But the ratio, the regression functions are almost the same. They're very similar. So what is this telling you? It's telling you we're not going to get the aggregate elasticity right, but we're going to get the differences across products approximately right. We're going to get the cross-substitution patterns approximately right. That makes sense because this is the same beta 0 that goes into every calculation. Every elasticity and every cross-elasticity has the same beta 0. So if I screw it up, okay, I move all of them, but I move them all together. Okay? So that's what's going on here. These are sort of interesting also because you can see where the markups should be higher, okay? And they're going to be higher in the minivan where it's more negative, where the elasticity is more negative, lower, okay? So it's going to be higher in the minivan and the SUV. That's where and that's exactly the incentive. Remember, those are going to be the markups. That's the incentive for new car development because it's the markups that give me the profits from the development expenditures. Okay, that's where you expect people to enter the market, and that's where they did enter the market. Okay? Okay, so now let me go to Control-Shift+. Okay, so these are the elasticities. So what we did in this paper, but there's 200 products, so I can't give you a table with 200 products. against 200. You won't read anything. Okay, so we took the 2 highest selling vehicles in every class of vehicles, and we're giving you the numbers for those 2 highest selling vehicles. Okay, so the Metro and the Cavalier were the subcompacts. Okay, their price was $7,840 and $11,000. That's their semi-elasticity. The best substitute is a Tercel and an Escort, which are also in the same class. And the second best substitute is a Festiva and a Tempo. What are the substitutes we increased by? I can't remember what we increased by. Some amount. We looked at some amount of money. Is that clear? We looked at where everybody went, okay, as a result of that, and we got the first and second best substitutes, okay? And that gives you the movers and the percentage outside good. You guys can look at this at your leisure, but you can see that it all makes a lot of sense. So, you know, the Lexus 400 series, which is the high-end Lexus then, okay, it substitutes with the Mercedes and the Lincoln Town Car. The Metro is satisfied with the Tercel and the Festiva. I go down to a Jeep Grand Cherokee, and it substitutes with the Explorer and another Cherokee, which isn't the Grand Cherokee, okay? And you can just see they all make a lot of sense. I'm not going to spend too much time on them. Okay, so now I'm going to compare the best substitutes from our model to the best substitutes to the Logit model, okay? So the best substitute for the Logit model for every car from the first choice data was the Caravan, except for the Caravan, which was the Voyager, and the Econometric, okay? So the Caravan is this, it's this van, big, heavy van, okay? And it's the best substitute for the Lexus 400 series, as well as everything else, okay? And if you use the first and second choice data, it's the Ford full-size pickup. Everybody, if they moved out of a Mercedes 500 series, they're going to move to the Ford, that's what the model is predicting, the Ford full-size pickup. And if you have moved from a Tercel or a Metro, you're still going to move to a Ford full-size pickup, okay? So what's going on here? Remember, what's happening is the substitution patterns are determined by the interaction between product characteristics and individual characteristics, okay? The individual things, even though they all came out significant and there were 30 of them or whatever it was, okay, they were dominated by the unobservable characteristics. Is that clear? And when you put back in the unobservable characteristics, okay, they mattered a lot. And you could tell they mattered a lot because the people who bought a Mercedes really did move to the Lincoln. We saw that in the last thing, okay? But they moved to the Lincoln not because of observable things, okay? They moved to the Lincoln because of the unobservables. If I didn't have the unobservables there, what would it say? Well, there wasn't much variance explained by the observables. Even though they were all significant and they all made sense, there wasn't much of the variance explained by them. So the Logit takes over. What happens when the Logit takes over? It goes to the car that has the biggest share, because that's what Logits do, right? And the car with the biggest share actually was between the Caravan and the Ford full-size pickup because there were no other full-size pickups in the market. And there were no other vans than the Dodge. There was others, but a very small number compared to family-size cars. Is that clear? So this is, remember I said at the beginning, I said, look, we get rid of some of this by having observable characteristics, but if you don't have enough observable characteristics, it's still going to come out in spades. And it did. Okay? So it shows you the importance of allowing for unobserved characteristics.
So I just want to be clear here what you're saying. So if you had even more observed characteristics, then it might be okay with substitution.
So if you had the right observed characteristics, okay? So for example, just think for a second, what determines whether you want to have a van or you want to have a minivan, okay? Well, one of the things that determines whether you have a minivan is whether you got to take 10 kids to the soccer game. That's just not in our data, okay? Or one other thing that determines whether you want a big car or not is you have another car. Is it a small car or a big car? It's not in our data. Maybe if we had those things in our data, then the unobservables wouldn't matter, okay? So it's that kind of logic that you have to think through, okay?
So most realistic situations and the substitution patterns implied by Logit would be implausible.
I think you'd find that for a lot of things, okay? Yeah. You know, the one thing, you do pick up a fair amount on price itself. Like the income terms, we got 3 or 4 different terms interacting with price, and we got a lot of that. But once you get to the other characteristics, you often don't have. So income really does determine what people buy, okay? But, you know, when you determine whether you're getting a minivan or a Mini Cooper S, you know, it depends whether you have your other car as a big car and whether you've got to drive kids around and stuff like that. That just isn't in the data, okay? So it's important. They can be, at least in this example, and they can be very important, okay? Okay, so now I'm going to go back to prediction exercise. So remember, one of the things we want to do is find out cross and known price losses. The other thing we want to do is do prediction. Remember, one of the reasons that you went to characteristics-based model is I want to predict what the demand would be for a new car, okay? And I can't do that in product space. Is that clear? So GM actually asked us to do the 2 prediction exercises that I'm going to go through quickly. One was to use the demand system for the evaluation of potential demand for a new model. They were deciding whether to build a high-end SUV, okay? And they want to know what would happen if we put a high-end SUV into this thing, okay? So that's going to be my first prediction exercise. And the second prediction exercise, it was they were thinking of shutting down the Oldsmobile division, okay? Why did GM think about shutting down the Oldsmobile division? Because they had 4 other divisions that were doing family-sized cars. There was Buick, there was Pontiac, there was Chrysler, not Chrysler, I don't know, I'll show you in a second, okay, they're all up here. And they thought that they were actually just cannibalizing themselves. Is that clear? So if people didn't go to the Oldsmobile, they were going to go to one of the other GM cars, family-sized cars, okay? And there was a lot of cost to keeping the Oldsmobile division going. Okay, so that was the question. And the question they asked us is, if we got rid of the Oldsmobile division, the whole division, there were 5 cars that they were being produced, well, where would people go? Okay? So those are the 2 questions we were asked. So, by the way, Oldsmobile division has been discontinued. Okay? So there is no more Oldsmobiles produced in this country, anywhere, actually. Okay? So they actually went through with it in the end. Okay? Okay, so what we're going to do is we're going to put in a new SUV, you know, a high-end SUV, and we're going to take out, then we're going to take out the Oldsmobile, and we're just going to recalculate stuff. Okay, that's what we're doing. Okay. There's a couple of problems with that. Right. First of all, the major problem I think is the data we're going to use to recalculate things is 1993 data, and they're not going to kill the Oldsmobile until 1999 or something like that. I can't remember when they actually killed it. They weren't going to kill it for a while, and you know, and the other markets, the other goods you're competing with in 1999 are different from the goods that you were competing with in 1993. Okay, but still, you might get some idea of what's going on by looking at the 1993 data. The second problem is that there's an issue of what the prices would be with a new SUV. Okay, with a high-end minivan. I'm sorry. Or a high-end SUV, I can't remember which one we did. I think we did, I'll see you on the next page. Okay, and what the prices would be if there was no Oldsmobile. So we could recompute prices. We didn't do that, okay? We actually did a regression function for price, like a hedonic function, because it didn't seem to make much difference, whatever we did, okay? And then the other thing is we're not going to, so the other cars are going to be held constant in the 1993 cars, which definitely is wrong, okay? This is going to be particularly wrong when you go to the high-end SUV, because it's true that the high-end SUV, you know, there was none. Ford Explorer was the highest of the high-end SUVs, but everybody put in a high-end SUV, not just GM, which put in a Cadillac, okay? You know, there's the Porsche Cayenne, there's the Lexus, the 300 series, and then the 400s. Just everybody put in. So it's different from what they would get. But anyway, we'll look at the answers. So just to show you the kind of problems you run into here. So the 2 new SUVs we put in were a Mercedes and a Toyota. Okay. So the question is, we're going to put them in. We've got to put them in at some set of characteristics. Is that clear? So we put them in at the Ford Explorer characteristics, but we didn't want the quality term, the C, to be the same as a Ford Explorer, because it was going to be a Mercedes or a Toyota. Okay? So we put it in as the average XC of the Toyota cars in the market, okay, in that year. And then we did a price regression on X's and X's. Okay, so we put Toyota in. You could have taken a random draw of X's for Toyota and Mercedes. Is that clear from the distribution of X's? Okay, but you don't believe Mercedes is a random draw from the distribution of X's. Okay, so we put in the actual average for the Toyota. Okay, and actually the low end of Mercedes one. And the reason the low end one is because the high end one just was so much out of sample for the SUV stuff. We didn't believe it anymore. Okay. So we're predicting quite a bit out of sample because the Toyota's SUV price was $30,240, we predicted, okay, which was $4,500 more than the high-end SUV that was in the market then. So this is really high-end for that. And the Mercedes SUV was $8,000 higher than the highest-end car SUV in the market. Okay, so you're comparing a car which was, you know, $25,000 to $33,000, which is a different part of the market. Remember, this is old dollars. Okay. So this is the table for putting in the Mercedes.
I have a
Yeah.
So you can only put the unobservable factor there if you were able to estimate point noise and deltas and the betas, right? But if you had to make an assumption on the distribution of the C's instead, you wouldn't be able to do what I mean?
So here's what you could have done, okay? I'm not sure I know what you mean, but I'll tell you what we did do first of all, okay? There's a delta there,
Right.
okay? And so all we have to do is add C to it, okay? Okay? There's an issue, so the whole, again, the C is an unobservable, okay?
Right.
So, you know, it's, what I essentially said was the assumption that C given the characteristics is mean the C given the characteristics is 0 is probably wrong. I wasn't willing to go with it from the Toyota, for the Toyota and the Mercedes. Is that clear? Because it said, you know, then it's the characteristics of the Mercedes go with a high C. Okay? But I didn't want to go with that to taking a random draw. Okay? Okay. You know, in reality, what's going on? Okay, the X's are produced along with the X's. Is that clear? So, you know, even just from the cost of production side, okay, they're going to be correlated. Okay, we don't know what the X is, but they're going to be correlated because a firm's, you know, it's not like the costs are additive in this. There's, you know, they're related to the car size, the engine type, and all that type of stuff. The hope in going to stuff like BLP and things like that's the one that Aviv showed you that I really like a lot is that the CT minus rho CT minus 1, remember that assumption is 0? That made a lot of sense to me. And the reason it makes a lot of sense to me is the X's are fixed for the product once it's introduced. The C can change because people's perceptions of the car can change and, you know, new reports come out on the car and everything like that, okay? But those things should be independent of the X's because they're already fixed at some level. Is that clear? So these are innovations that people didn't know about when the X's were fixed. Is that clear? Because we have XC, which is the initial perceptions. Okay? So that might well be correlated with X for many reasons, okay? So if Mercedes is pushing the car, you know, it's probably a high-end car, okay, with a lot of quality stuff, okay? But now that I fixed that and I look at the increment or decrement and the perception of that over time, that may well be independent, okay? Which is, Aviv showed you this. I think Andrew Sweeting was the first, well, one of the first. We said this in VLP that we should be doing this, but we didn't think we had enough data. Somewhere in some footnote somewhere, I remember, okay? Anyway, you can see what happened here. This is the high-end Mercedes. It did very well. It did very well in the market. It got a share of, the price was $33,000, and it got a share of almost 0.1, which, remember, only 10% of the people buy the car, and there are 200 cars in the market. Okay, got it mostly from the Ford Explorer and the Jeep Grand Cherokee, okay? So mostly from exactly who you would expect it would get. That's what we're predicting anyways. And people who switched almost entirely there was almost no gain in the total number of people who bought cars. Okay, it was all from other cars. Okay? Okay, so that was what happened for there. I'm right on time, so I'll just finish this. Now here's the Oldsmobile division. These are the 5 Oldsmobile cars, and we just assumed they were shut down, they were taken out of the market. Okay, and we recomputed the equilibrium. And you can see, you can see why GM thought that that it might be a good thing to do. The Chevy Lumina, the Buick LeSabre, and the Pontiac Grand Am, they're all GM cars. These are the best, these are the cars that lost the most share, that gained the most share, I'm sorry. So the Oldsmobile goes out, people switch to other cars, okay? And the question is, which cars did they switch to? Okay, and in particular, did they switch to GM cars or not GM cars? Okay? So you can see what's going on here. The first 3 are GM cars, and so is the Saturn. But in addition, there's the Honda Accord, the Ford Taurus, and the Toyota Camry there. The rest of them, so those aren't GM cars. So some people are switching to other cars, okay? Ford Taurus was the highest selling car in those days. Okay, I think it might still be. So they lost all the Oldsmobiles, but some people switched out of cars entirely, but a very small fraction of them. And about 0.11 out of 0.237, which I guess is about 40%, shifted out of GM cars, which is a big shift. Which is a big shift out of GM cars. Okay? So again, they went ahead and did this anyway. Okay. Even though they were worried about their answer to this one. Okay? But they did it, they took their time. They did it about 10 years after this. So that's it for this lecture.